This is Michelle Sullivan. I'm in Vancouver at the Alzheimer's Association's International Conference. I'm speaking with Dr. Mike Wolff. He's a professor of neurology at Harvard Medical School about one of the really hot topics here at this meeting, a recent finding of a rare gene that confers protection against Alzheimer's disease and how that has some implications in research for a possible therapeutic method. Dr. Wolff?
Yes, it's a very exciting finding. As many people know, there's been a lot of skepticism about the amyloid hypothesis, trying to target amyloid with therapeutics to treat or prevent Alzheimer's disease. And this mutation is an important validation of that approach, that we're not in fact wasting our time going after amyloid as a target, because those mutations, this particular mutation happens to be in the amyloid precursor protein, right next to a cleavage site that is, it's a site that's cleaved by beta-secretase. Mm-hmm. And so what happens with these mutations is people who carry the mutation have less amyloid throughout their lifespan, and they're protected into their 80s and 90s from cognitive declines that typically happen to people by that age. In fact, if we live to be that age, we have about a 50% chance of having Alzheimer's disease. So it's a remarkable protective effect, and it's right near the beta-secretase cleavage site, and it validates beta-secretase as a target.
What exactly is the action of beta-secretase on the amyloid precursor protein?
Right, so beta-secretase is a protease that cleaves the amyloid precursor protein, and it makes one of the ends of beta-amyloid. Gamma-secretase produces the other end, so you need two cuts, one by beta-secretase and then another by gamma-secretase, and that produces beta-amyloid. And so you need beta-secretase to generate amyloid.
There have been some problems with these secretase inhibitors. They're poorly tolerated in their phase 2 trials.
Yeah, so that's true of gamma-secretase inhibitors. Beta-secretase inhibitors, I think we have to see whether they're going to be poorly tolerated or not. I think it's early days for beta-secretase inhibitors. It's taken a long time to develop those agents because it's been very difficult to get compounds that work in the brain. That's been the difficulty targeting beta-secretase, is having compounds that potently inhibit that enzyme, but that can access the brain, do what they need to do, where they need to do it. The problem is that we don't know when we need to treat people with a beta-secretase inhibitor. It could be we have to treat quite early, way before signs and symptoms of Alzheimer's disease happen, in order to get that protective effect. So we'll have to see. But there are some promising agents at this meeting that are in the pipeline that target beta-secretase. And so I think we'll have some evidence that that approach can work soon.